Hello, this is Gavin Blue here, and I have with me now 1 gram of pure cesium. This is one of my favorite elements because it actually melts at around 80 degrees, around body temperature. I could melt this in my hand. And it's just such a cool element to have because it's used for such obscure things that honestly almost nobody knows about it. But I'm here to share with you some of the properties. First off, cesium actually gets its name from sky blue because cesium, despite the golden color that it obviously has, its plasma is actually about as blue as the sky, hence the name. It was originally discovered in some point in the 1800s by some scientists whom I don't know the name of. Cesium is an alkali metal, which means that it reacts very violently with oxygen and water, and some even nitrogen. So it's necessary to keep it in this ampule to protect it from all those reactants. You see, it's starting to melt. Cesium is actually the most reactive alkali metal, other than francium. But technically, francium is actually less reactive simply because it's radioactive, and a lot of its energy goes to that instead of actually reacting. Look at that. It's almost fully liquid. It almost looks like liquid gold. But if I were to ever open this, or if this were to break, the cesium would spill out. It would burn with a purple-blue flame, and it would turn black within seconds. And this wasn't cheap either. A gram of cesium is around $80, but I was able to get this sample for $59, not including shipping. So it ended up actually being around $78 to ship to me. Like I mentioned, cesium is a low melting point metal, similar to gallium, which may be in my next video. Cesium is really, since it's an alkali metal, cesium is softer than, well, say you put butter in the microwave for like 10 seconds. It would be softer than that still. And cesium is also one of the only other metals that naturally has a golden color to it other than gold itself. Cesium is element 55 in the periodic table. It's kind of late. It's almost halfway there. If you look at this periodic table behind me, cesium is the 55th element. Its atomic mass is 132 and 905 thousandths. The sample in here, it's probably cesium chloride. You see above it, we got rubidium, potassium, sodium, lithium. Every one of those are alkali metals, just like cesium. Cesium is above francium, but it's radioactive. Francium's next to radium, which is also radioactive. Cesium is one of the last metals that are actually, not dangerous. Back to the actual metal. This here ampule is protected in argon. Argon, of course, is an inert gas, so it's good for preserving things that, like steel, from tarnishing, because, the argon doesn't react with it, and the thing that rusts iron or steel or cesium is oxygen. So argon is used to protect these reactive elements from that. If you noticed, the cesium sticks to the glass on a couple of the sides. Hold on. Look. It sticks to the sides of the glass. That's because this is only 99.99% pure. I think it's only 99.9. So that means the more pure the cesium, the less it'll stick to glass. And it's relatively, inert to the glass. It doesn't really stick to it very much. Only in that one spot. Now when you shake it around, look at that. It coats it. It looks like a golden pill. Look at that. Reflecting the light behind me. Cesium is probably one of my favorite elements. I made a video about it months and months ago when I was just first having my element collection. This sample came from Luciteria, and I'm thankful for them to provide me with this. Cesium is actually very hard to extract from, other chemicals or ores because, well, it's really reactive. You need a specific apparatus set up and plenty of argon, and you have to distill this to actually get it over looking like this. If you don't distill it, it's going to probably coat the glass similar to how gallium does. If you've ever played with gallium before, you know that it gets stuck to your hands. You have to scrape it off. That's because it's reacting slightly but truly to the oxygen in the air and the oils on your hands, coating them. And because it's also just a pretty sticky metal. Thing about cesium is that its boiling point is similar to that of water. I could heat this up, and if I waited long enough, I could literally make this turn into a plasma. That's probably all I got. I'll provide you with a time lapse of it cooling off.